All right, so let me know if y'all can hear me okay. We'll give it a couple minutes before we get started here. I'll let everybody join the stream tonight, but let me know in the live chat if you can hear me okay. My microphone sound okay? Awesome. Awesome. We'll give it a couple more minutes before we get started, but let people roll in. Let me know in the live chat where you're watching our stream from tonight. Where in the world are you tuning in from? East Bay, California, Jacksonville, Florida, DC, Colorado, Austin, Texas, California, Morocco, Seattle. What time is it in Morocco? London, Croatia, 2:30 a.m. Wow. That's dedication. Portugal, Idaho. Brazil, New Zealand, Argentina, Memphis. Guatemala, India, Savannah. $2:30. Greece. Brazil. Monterrey. 1:30 a.m. Buenos Aires. Guadalajara. Sorry, my Spanish isn't great. All right, let's go ahead and jump in here, everybody. So welcome to the Trading Bot Masterclass, okay? So I'm super excited to show you how to create your own blockchain-based trading bot. You know, a lot has happened in this space. There's a ton of opportunity happening all the time with trading bots. I don't know if you saw my video a couple weeks ago about the developer, or I guess it was last week, developer making $10,000 per day, with their trading bot. I've seen different developers making, $130,000 in a single transaction. That's pretty crazy. Okay. I put out some videos on different strategies you can do to do this. And so I was super excited to get you the nuts and bolts on how to build one yourself. All right. So what we're going to cover in brief, we're going to give you everything you need to know to create your own blockchain-based crypto trading bot. Talk about the concepts that you need to understand in order to do this, and then how to actually write the code to implement it. All right. So a couple quick house rules. Before we jump into our presentation tonight, number one is let's definitely stay in the YouTube chat to ask questions. Okay, there's a lot going on for me to look at different monitors and present and answer questions. We've got people in the blockchain mastery community, who are in the Slack channel. So we got people on Twitter. We got people everywhere. Just make sure that you are asking questions in the YouTube live stream chat. That's what I'm going to pay attention to while I'm presenting tonight. Okay. So that being said, for the fine people of Blockchain Mastery University, they've been a part of our monthly masterclass series. They've been watching our weekly updated videos. They're inside of our community chat. So, if you want access to that type of stuff and you didn't join that when you joined the masterclass tonight, definitely reach out to Gregory at dappuniversity.com and get you taken care of. So that being said, we will have questions throughout this presentation. I will periodically kind of take some breaks and monitor the chat for questions, but let's save most of the questions until the end, okay? We'll have an extended period of time for Q&A. I just want to make sure that I can give my full attention to the presentation and not be constantly looking back and forth. So another way for you to get the most out of the presentation tonight is really just watch what's happening here and try to get the big picture, okay, you know, you're probably going to fall a little bit behind if you try to code everything along, step by step while we're doing this. It's okay if you try to do some things, but, don't feel like you have to get everything in the first go around tonight. We're going to have a replay link emailed out to you if you just join the one-time class tonight, or if you're in the blockchain mastery program, we'll have a replay up in the video vault. You can always go back to that a second time and get the details. Okay. Tonight's definitely a time for getting big picture and, ask any specific questions that are unclear. And so, we're going to show you everything, how to get that set up, how to run the bot, how to customize it. We're not going to do everything in terms of step-by-step coding, but if you want, the full-on, knowledge and how to code this step-by-step from start to finish, and definitely check out the Blockchain Bootcamp. There's a link in the description below. That'll be a special discount just for joining tonight's presentation. So, and last but not least, there's a ton of amazing opportunity in the trading bot space. That being said, as I talked about in my YouTube videos, and I'll talk about tonight in this presentation, the best way to be competitive with that is to create your own strategies. Okay. And so for that reason, I can't give you any promise of any type of financial return based on the strategies that you implement. Okay. I can't officially give you any type of financial guarantee for that type of thing, obviously for legal reasons. This is for educational purposes only. Okay. And so, I'm holding this class by popular demand to talk about how to create a crypto trading bot and all that type of stuff. So we'll stick to questions around that type of thing. And I cannot promise you a certain outcome. Okay. So anyways, just so we're all clear, I'm super ready to jump into this, super ready to show you everything that you need to know. This is going to be awesome. You can get a ton of value from this presentation. So let's get started. All right, so let's start out with some basics, okay? Let's start out first of all and talk about this crypto trading bot. Let's dispel any misconceptions. What does it do? What does it not do? Let's first start off with what does it not do, okay? So, a lot of people hear crypto trading bots and think like, hey, that's never going to work. Like, how could you accurately predict the future price of cryptocurrency all the time? Like, I don't know if you try to trade crypto, I can never figure out exactly when it's going to go up and down on any like short time frame, right? So how could you expect a bot to do that accurately? Most crypto trading bots that try to do that end up totally blowing up, okay? And they end up losing all your money. And for that reason, a lot of crypto trading bots get a bad reputation. But that's not really what this bot does, okay? It doesn't try to predict future crypto prices. This is a bot that essentially takes advantage of opportunities right now in the marketplace, okay? So most trading bots, again, you need to put your money into this thing and it can just bet wrong and totally chop up your account and lose all your money. But this bot's different. It capitalizes off opportunities that exist in the marketplace right now. It's a blockchain-based trading bot, and you really don't have to, you can't really, there's no risk that you can lose money that you're trading with. Now, you will have to pay some gas fees in order to attempt some trades. And if those trades are unsuccessful, then you, of course, could lose out on those gas fees. But that's negligible compared to, putting a bunch of money into a bot and watching it just drain your entire account balance. That's not what's happening here. So benefits, you don't have to predict future cryptocurrency prices. You can look at opportunities that exist right now. You don't need money to trade, and you really can't lose the money that you're trading with. So let's talk about the features of this bot. It is an arbitrage-based trading bot. It profits off of price discrepancies in different cryptocurrency exchanges as real-time opportunities that exist right now. It's powered by smart contracts on the blockchain, okay? It uses flash loans in order to borrow the money, which means that's how you don't have to have any money to trade, and you can't lose that money whenever you borrow it. We're going to get into all of those things individually, but that's the high-level overview, okay? We're going to cover the concepts, everything you need to know to start creating your own comprehensive overview of how the bot works. We'll talk about the implementation, the actual coding implementation, the setup, the demonstration, how to customize it to create your own strategies, and finally, what blockchain we're going to focus on. We're going to focus on Ethereum, okay? But this will apply to many, many, many other blockchains out there that work just like Ethereum, where you can use Solidity smart contracts called EVM compatible blockchains, and also layer 2s. We'll get into that, okay? So one final disclaimer before we get into this, we're going to show you how to create your own trading bot, ultimately so that you can create your own strategy so that you can start doing this. So I've done this class in the past where essentially I've just got a strategy and like plugged it in, okay, and then like started doing trades with it, and then present you with the strategy with the profitable transactions. But there's a problem with that. There's a problem with that. We did that in the past, and then the strategy just stopped working instantly. That's because once everybody gets a hold of the exact same strategy that I use, then everybody's just competing with one another. Okay. And then you're just competing with one another, trying to be the fastest person to execute that strategy. And that's not really a great opportunity, right? So, that's how trading bots kind of tend to work, where if you try to do the exact same thing as somebody else, you have to outcompete that person. That applies to the real world. You can look at what different developers are doing out there in the blockchain, and you can try to compete with them, but that's not really what I've tried to do. Okay. And that's not what I suggest that you try to do. So I suggest that you try to essentially create your own strategy where you're looking for other opportunities and getting creative in ways that other people aren't. We'll talk about that towards the end of this class tonight. But in order to do that, what you're going to want to do is take an existing solution, which I'm going to give you tonight, and I'm going to show you to customize it so that you can start implementing those types of strategies. That's what you have to do. I'm going to show you how we can do that in kind of a flight simulator type of environment where you can simulate the real world blockchain and all the apps, all the tokens inside of it, and then we can reproduce the conditions for a profitable trade. And then you can see the mechanics of how that works. And then you can go start doing that with these different variables and tweaks that we'll show you later on different parts of the blockchain with different strategies. Okay. So tonight it's going to be kind of like flying in a flight simulator. Okay. And then, you have to fly that simulator before you get in a real airplane and take off, because that's no way to learn how to fly an airplane. All right. So let's jump into the conceptual topics that we have to get right. Ooh, that looks terrible. Before we jump into the coding. All right. So let's start off with some basics. Like, what is arbitrage? Okay. That's key to understand when we're talking about an arbitrage-based trading bot. So arbitrage is basically buying something in one place and selling it for a higher price in a different place. You see this all the time with like car flippers, right? House flippers, antique furniture, rare goods that somebody might go purchase, on their travels and bring back to another country and sell for a higher price. It's basically finding something that someone else is going to pay a higher price for somewhere else. So that's what arbitrage is. You can do this with cryptocurrency exchanges, cryptocurrency. All right. So you'll see that cryptocurrency is very volatile. So the price is always changing. And for that reason, exchanges might fall out of sync with one another. Okay. So you might see a theoretical cryptocurrency that is essentially trading for $100 on one exchange. And then maybe it sells for $101 on a different exchange. That's a $1 price discrepancy. All right. Now, if you bought it for $100 on one exchange and sold it for $101 on a different exchange, that's an arbitrage, the profit of $1. Now, not that many people on this call are going to get excited about a $1 profit. But the whole idea is, what if you could do that with 1,000 tokens, right? That'd be $1,000 in profit. Or if you could do a $1 profit 100 times, right? That'd be $100 profit. Okay. That's the idea of what an arbitrage is and how you can do it to make money on different exchanges. Okay. Now, you can do arbitrage on regular cryptocurrency exchanges. Let's say that you bought coins on, say you bought Bitcoin on an exchange like Coinbase. Okay. Let's say right now, Bitcoin, let's just look at the Bitcoin price. Let's look it up. So Bitcoin currently is $18,778, right? So let's just say it's trading for $18,778 on Coinbase, and then you sold it for $18,900 on Binance, right? You can make a $200 profit on one Bitcoin, right? So you can do that. Those are called centralized exchanges. Bitcoin is, traded on both of those. But what if the price of Bitcoin moved on you? Well, you could lose money on that because the time that you bought it, the time that you sold it, the price might change. It's very volatile. Now, the thing with blockchain is you've got decentralized exchanges powered by smart contracts that are all on the exact same blockchain, and you can do arbitrages in a single transaction that plug into each of those exchanges, where when you execute that trade, you're doing it in real time with instant access. You're the star of the show, and the price cannot move on you. That's the beauty of blockchain-based arbitrage, is that you can plug into these different decentralized exchanges powered by smart contracts on chain, and you cannot, the cryptocurrency price can't move on you while you're attempting that trade. All right, so let's get into the next topic, which is, what is a flash loan? Okay, this is part of the secret sauce on how this works. Okay, so a flash loan is the ability to borrow, millions of dollars of cryptocurrency basically for free, without putting any money down, and there's no risk that you can lose that money as long as you pay it back in the same transaction. Well, there's never a risk that you can lose the money. What I'm saying is, it's borrowing all this money as long as you pay it back instantly, basically. So you might say, why on earth would you want to borrow money instantly and pay it back instantly? Well, that's what you can use it for. You can use flash loans for things like liquidations. You can use it for things like arbitrage trading. Use it for leverage and DeFi. Okay. So let's explain the idea of simple versus complex transactions on the blockchain, because that'll sort of demystify how this works. So blockchains support simple transactions with one instruction. Let's say that I sent cryptocurrency from my account to your account. Well, that's a transaction that just has one simple instruction. It says, take money out of my account and put it in yours. Not necessarily two things, but it's really just one instruction, right? So, if you did that in your wallet, that's a simple transaction that gets included on the blockchain with that one instruction. Now, you can create transactions with multiple steps, all right? And that might look like this on my screen. Step one could be borrow some money. Step two might be, say, like, do something with it, like go trade it on an exchange. Step three might be like pay it back. And then step four might be keep the profit, okay? So that's the idea of a multi-step transaction. And that's how a flash loan comes into play. As long as you can borrow this money and do stuff with it and pay it back in full and have some profit left over, that's a successful use of a flash loan, okay? And the beauty of that is, let's say you try it and it's unsuccessful. Well, then there's no way that you can lose the money. So you can't be on hook like for this $1 million if you borrow it, because if it fails, it's just not going to really give you the money in the first place. I mean, it is, but the transaction won't actually finalize. Okay. So that's why it's risk-free. Okay. Now, that's because, you're doing these transactions inside of smart contracts. The way that you create complex transactions on a blockchain is to create functions inside of a smart contract that have multiple steps associated with them. So every line in a function that you make is the exact steps that I'm showing you here on the screen. So that's exactly how the flash loans work with arbitrage. Okay. So let's just see here. Now, a couple caveats with this. Just because you can borrow $1 million to do a flash loan doesn't mean that you have to, right? You could basically borrow less. It just depends on how much money you need to trade. Now, when I say zero money down, that means you don't have to put any money down to do the loan. Now, there will be a small fee depending on this flash loan provider that you use, but there's some cases where the fee is basically negligible, or some places where the fee doesn't even exist at all. I'll talk about some options on that tonight. Okay. All right, so let's cover a few other fundamentals here. Let's talk about the different cryptocurrencies that this supports, okay? Because before I was saying that we're going to use the blockchain Ethereum, all right? But other EVM compatible chains like Polygon, Binance Smart Chain, Ethereum Layer 2s, et cetera, et cetera. But let's talk about which cryptocurrencies this supports. So some people might get confused and think like, hey, can I do arbitrage trading with Bitcoin? Well, you can on regular exchanges, but you can't really do it with the technique that I'm talking about tonight natively, right? What this is going to support is tokens. So ERC 20 tokens. All right. So ERC20 tokens are basically the thing about blockchains like Ethereum is that you can create your own cryptocurrency without creating your own blockchain, which is nice. And the tokens are powered by smart contracts on top of the network. And you can, trade any of these ERC20 tokens with the technique that I'm talking about tonight. Pretty much a vast majority of the cryptocurrencies out there are just ERC20 tokens. Okay. Some of them are native gas tokens, but these are just, ERC20 tokens. And so if you look up any ERC20 token, that's what you could potentially trade. Now, what is ERC20? Well, basically, it's just a standard that describes how these tokens work. So they're compatible with things like cryptocurrency exchanges, blockchain wallets, et cetera, et cetera. Okay, so we'll see the ERC20 standard in motion tonight as we boot this up and start running this bot. And so another thing to understand is, you have to be on the same blockchain in order to do these transactions that I'm talking about tonight. Sometimes people ask me about like cross-chain arbitrages and stuff. That's not really what we're going to get into. I haven't even found really good solutions for that type of thing yet. All right, so let's look at our next sort of concept to understand. Let's talk about decentralized exchanges or DEXs, okay? So, you might have seen an app like Uniswap. So Uniswap is the most popular application on the blockchain. It's a decentralized exchange or a DEX, okay? Which basically means that it is an app that's powered by smart contracts in the blockchain that lets you trade tokens. You just tell it which cryptocurrency you have and which cryptocurrency you want to trade, okay? And then you just say, I want to trade 1 Ether, and it tells you how many, 1-inch tokens that you're going to receive for that trade, and you just click swap, and it does the swap for you, okay? But how does Uniswap work? Well, again, it is a decentralized exchange. So on the back end behind this website, it are the smart contracts on the blockchain. And so those smart contracts basically look like this. The website talks to the main smart contracts for Uniswap. And then it talks to these. Uniswap is what's called an automated market maker, which basically means it does exactly what I was talking about. It works kind of like a vending machine. You see this website, there's no order book or anything. You just tell it which cryptocurrency you have, which cryptocurrency you want to buy, and it does the swap for you. You don't have to like open a limit order or anything like that. There's no order book. All the cryptocurrencies just parked inside the app, because you might be wondering, hey, well, where are these tokens coming from that I am going to borrow, or not borrow, but swap? Where are they? Okay. So they are in the app. All right. They're in the smart contracts on the back end and these things called liquidity pools. Okay. And you have to understand liquidity pools because we're going to use liquidity pools inside of our example tonight. So what's a liquidity pool? Well, basically, that's what gives the app tokens to trade, okay? So basically, if you've got, so where do the tokens come from? Well, they come from people called liquidity providers who basically park their cryptocurrency into these liquidity pools, in order to get some sort of passive income reward for doing that. That's the incentive for giving the app money, all right? And then it gives Uniswap the liquidity or the tokens that it needs to facilitate trading for the website, okay? And so you can see different examples. Liquidity pools typically have a pair of 2 tokens. So you can see example here like USDC WETH pool and the Shiba Inu WETH pool. So these are 2 different pools that we're actually going to use tonight. So when you're doing arbitrages, you are basically going to be plugging into each of these pools to check the reserves and get the prices, and you'll basically be arbitraging these different pools on different exchanges. And now the beauty of these decentralized exchanges or DEXs is because these are smart contracts that live on the blockchain, you have open access to this stuff, okay? You have open access to the Uniswap smart contracts so that you can write your own app that plugs into them and does whatever you want to. And that's exactly what you're going to be doing when you're creating your own trading bots, because you're going to be plugging directly into the Uniswap smart contracts with your bot. So let's take a look at how that works. So here's the anatomy of the trading bot. All right. So I've got this kind of broken out into multiple layers here. Let's start off with the smart contract here. Okay. So you're going to have one main smart contract that serves multiple functions. Okay. What this thing is going to do is it's going to facilitate the trades. It's going to buy cryptocurrency on one exchange and sell it on the other exchange. Okay. That's the main function here. It's also going to take out the flash loan in order to do that. And then, yeah, let's get into the details here. So, and also on this line, this is a line that shows you where the layers are. This is like on the internet on your computer, and this stuff down here is on the blockchain. So your smart contract, it's going to be written in Solidity. Okay. It's the trading contract. It's got the rules that govern, how you're going to do this trade. It knows how to talk to the Uniswap smart contract. It knows how to talk to the SushiSwap contract. That's exchange A and exchange B. Okay. It knows how to do the trades on each of those. You program all this stuff in here, and then it plugs into the flash loan smart contract to borrow the money in order to do this, also pay it back, and then also to keep the money so that you can withdraw it after you have done these trades. Okay. And so, the DEX over here is the DEX contract. In examples, Uniswap or SushiSwap. Here's like token 1, which is an ERC20 token. Here's token 2, which is another ERC20. You're just swapping these tokens around these two exchanges. All right. Now, finally, let's talk about what's not on the blockchain. So this trading contract is something that does, the trades, but you have to tell this contract when to actually do the arbitrages. Okay. So you can't just, you can't just like let this contract on the blockchain let it do its magic. Okay. You have to actually call it. Okay. So that's what this bot's for. That's where the little bot comes into play. Here's the trading contract, but here's the bot. The bot is its own app written in JavaScript, okay, that watches the blockchain for these different price discrepancies. And when it finds one, it talks to your trading contract and tells it to do the arbitrage trade, okay? And then that contract takes out the loan, buys a cryptocurrency on one exchange, and sells it on the other exchange. So here's the blockchain side. Here's the internet side, or your computer, or whatever you want to call it, wherever you put your bot. And then that's what it's for. All right, so I'm going to answer a quick question. Somebody's about where's the Slack channel? So the Slack channel is for the Blockchain Mastery program. That's different from the Blockchain Bootcamp. So the Blockchain Bootcamp is a step-by-step program on how to become a blockchain developer. And the Blockchain Mastery program has the Masterclass series, has the Slack group. It's got weekly videos on different blockchain topics like flash loans, DeFi, arbitrage, NFTs, et cetera, et cetera. All right, so let's talk a little bit more about your bot. All right. So basically what it's going to do, this is the app. It's going to look at two different exchanges. It's going to listen to all the swap events. All right. And essentially what's going to happen is whenever new trades come in, it's going to say, can I profit? If yes, it's going to call your contractor to do the trade. If not, it's just going to say no, and it's just going to wait. All right. And then let's start with the arbitrage contract. So what it does is it takes the flash loan for token 1. It buys token number 2 on exchange A. All right. And then it sells token 2 on exchange B. And then it repays the flash loan of token 1. And then it keeps the profit. And the fail safe on that, if the transaction is profitable, then the transaction will revert. So why it might not be profitable? Well, you might make a bad calculation, or someone might beat you to the swap. It can't really lose you money, but if the trade fails, you of course will lose money on the gas fee for that. All right, so a couple other things before we get into the technical details. Let's talk about the opportunity here again. So okay, so let's talk about sort of the opportunity, especially about creating your own strategies. So before I was talking about, one of the best ways to do this is to start trying things that other people aren't doing and not try to compete with other people. So it's about all the different parameters that you can change in order to actually do this. So think about it this way. There's all these different tokens out there. I've just talked about a few tokens in this, um, you know, in this video. Okay. But if you think about it, like if you look at this token, that's 747,000 token contracts found. All right. 747,000 token contracts on one blockchain on Ethereum alone. Okay. So that's just one variable in the equation. Now, think about all the different decentralized exchanges are out there. I just talked about two. I've talked about Uniswap and SushiSwap, but here's not even a comprehensive list of all the different decentralized exchanges out there. Okay. This is 655 different decentralized exchanges. Now, some of the bottom are basically like ghost towns, but let's just even say the top 100, right? The top 100 still have at least, the top 100 are pretty close to $10 million in TVL, okay? And the top 10, it all have close to $200 million in TVL. The top 4 have over $1 billion in TVL. So there is a lot of different decentralized exchanges out there, a lot of money sitting in the liquidity pools, okay? And then think about the different blockchains, okay? Look at these different EVM compatible chains. You got Ethereum, Binance Smart Chain, Tron, Polygon, Arbitrum, Avalanche, Optimism, Phantom, Chronos, et cetera, et cetera, et cetera. There's so many different blockchains out there that you could potentially execute this strategy on. So you start tweaking all those variables. That's a bunch of different ways, to essentially, look for different opportunities in the marketplace. There's a ton of different things that you can try here. All right. And the last thing I'm talking about are different flash loan providers. So you can do flash loans in multiple different applications. Aave is one of the most popular ones. Aave is a savings and lending app. It's got liquidity pools that let you do this, and that's where the flash loans come from. So you can look at the Aave documentation to do flash loans. There's DYDX, okay, version 2. That's what we're going to use tonight because it's got one of the lowest fees and it's easy to use, okay? So that's sort of the combination that I like, which is low fees and easy to use, okay? Whereas Aave's got a higher fee, all right? Still pretty easy to use, but it's got a higher fee. And then if you want another one, Dodo is another one to look at. It has no fees, but it's harder to use, okay? And it is multi-chain, so that has another benefit. But yeah, just a couple different options for you with some caveats associated with them. All right, so now let's get into the technical details of this bot that we are going to create tonight. So we will get into the coding here very quickly, but I want to go over some technical details on exactly how we're going to do this, okay, that you have to understand before we get into the code, because the code's not going to make any sense unless you understand this stuff first. So Daryl Banks doesn't believe it's live. Yeah, it's definitely live. 12th of January, 2023. Yeah, it's live. Aave, Dodo, and DYDX. No, DYDX didn't stop providing flash loans on version 2. You can still use version 2. How much Subway is paying me? This is definitely not a sponsored Subway video. All right, so yeah, let's go over these technical concepts you have to understand. So let's go over these technical concepts. So let's look at this scenario. All right, we've got this, sort of line in the sand, which this is the blockchain side of things. This is the bot. So this is a very similar diagram, but it shells out exactly what we're going to do. So again, before I was talking about how we're going to use a flight simulator, you know what I mean, to essentially create this. So I'm going to show you how to reproduce a flash loan arbitrage. We're going to actually manipulate a blockchain to do this. I'm going to plug it into 2 different decentralized exchanges. We're going to arb real world cryptocurrencies in real time. So what's going to happen? So, but we want to keep this as simple as possible. So here are the key parts: the exchanges that we're going to interact with. Okay, we're gonna arb between Uniswap version 2 and SushiSwap. Okay, these are 2 different decentralized exchanges. The reason I've done this is because SushiSwap is a fork of Uniswap version 2, which basically means it's just a copy of it. Okay. And for that reason, they work the exact same way under the hood, basically. All right. They have the same interface, which means that if you know how to use one exchange and how to code for it, you can code for the other exchange. It basically works the same way. And there's lots of other exchanges that are Uniswap version 2 forks. And for that reason, if you learn Uniswap version 2, you'll basically learn how lots of other exchanges work as well. All right. So what cryptocurrencies are we going to arbitrage? We're going to arbitrage WETH, which is wrapped Ether. Okay, it's the ERC20 version of Ethereum or Ether. So basically, Ethereum is not a ERC20 token, but you can wrap it into a smart contract called WETH, and then it trades just like an ERC20 token, but it represents the value of Ether. Okay, and then Shiba Inu, also known as SHIB tokens. Okay, that's the other cryptocurrency that we're going to arbitrage in this case. All right. So yeah, we're definitely going to stick to our sandbox environment tonight. William's got a good point. If you start just trying this on mainnet without knowing what you're doing, you're just going to lose money. So William's right. All right, the flash loan provider we're going to use is DYDX, and the blockchain that we're going to use is Ethereum. Now let's explain the arbitrage sequence. Okay. So let's talk about the steps here. This can be kind of confusing because buy and sell gets a little arbitrary depending on what you're doing. You're just trading one token for another. But essentially what you're going to do is you're going to borrow wrapped Ether from WETH. You're going to trade it on Uniswap for Shiba Inu tokens. And then you're going to trade Shiba Inu tokens on SushiSwap back for WETH. So that's the whole idea. And you're going to pay back the loan and take the profit. So the whole idea is to start off with one token, WETH, trade it for SHIB, trade it back for WETH, and end up with more WETH than you had at the beginning. That's how you make a profit, but you borrow the initial capital to do this. All right. Somebody says that I tried equalizer for flash loans. It's multi-chain and it's 0%. No, I've not tried equalizer yet. All right, so let's talk about the environment that we're going to do this in, because before I was talking about how to use essentially, we're going to use a sandbox environment. So how does this work? Well, essentially what we're going to do is we are going to use a test blockchain on our computer that's going to point to the main blockchain. Okay, and then hold on, let me zoom this out. We're going to fork it, which means we're going to freeze the blockchain. And then that means that we can get access to all the accounts, all the smart contracts, all the balances, the apps, the tokens, exchanges, flash loans, et cetera, et cetera. And then we can replicate that on our computer and then connect it to our project, okay, so that we can actually write the smart contracts, do the trade. We can run our bot against that, and we don't have to risk losing any money, okay? So when we do that, essentially we're going to get a connection to the blockchain. We're going to freeze it, and that way we can manipulate it. We can get free cryptocurrency. We can pretend to be a big crypto whale, right? And then start trading things around. We can actually manipulate the cryptocurrency prices on chain so that we can create a real world arbitrage situation, and our bot can find it, and then we can call the contracts, take out the flash loans, and then do the arbitrage trade. Okay. So, what you'll need for this essentially is a setup, and you'll just need a connection to the blockchain. We're going to use Alchemy for that. I'll show you all that in a minute. All right. And my diagram is not 100% right. This says Ganache CLI. We're actually going to use the hard hat node for this presentation. And then this says Truffle over here, but we're actually going to use hard hat. So we've got a new updated version of this bot that's going to be using hard hat technologies instead of the Truffle technologies. We're going to use Ethers.js instead of Web3.js. So let's talk about how we're going to recreate the arbitrage opportunity. All right, so basically, instead of just sitting here waiting for an arbitrage opportunity to start, I see some people in the comment section kind of fighting about whether we should be doing this on mainnet or whether we should be doing it on the sandbox environment. One reason we're doing it on the sandbox environment, there's lots of reasons. One is I don't want you sitting here just blowing your money trying to make trades happen and deploying contracts and changing the code. Because you have to understand, when you're creating your own strategies, you're making code changes and testing things out. Every time if you had to make a code change and redeploy a smart contract, it would cost you so much money to do that 100 times, right? You would just blow through all your money before you could even attempt to trade. That's why you want to do it in a sandbox environment. The other reason is that in order to replicate this in the presentation tonight, there's no guarantee that I'm just going to be able to make an awesome, profitable arbitrage, right here while I'm talking to you. That doesn't always just happen like that, just instantly, right? So in order to show you exactly how to do it in a way that you can replicate it, we've got to do it this way, okay? So I'm going to show you how we're going to actually set up the scenario to make a profitable arbitrage happen, because you want a scientific environment where you can control all the variables and reproduce the exact same actions over and over and over and over and over again to create a strategy, okay? And that's exactly what we're going to do. So somebody says, don't do it. I may not give you the steps to do it. It's the exact same steps. Okay, so what we're going to do is we are going to essentially fork the blockchain, and we're going to pretend to be a really large whale of the Shiba Inu token. We're actually going to unlock their wallet. We're going to get the private keys to their wallet, and we are going to unlock that with millions and millions of dollars worth of Shiba Inu tokens, and we're just going to trade them on Uniswap and dump the price, okay? So when we trade that much tokens on Shiba, on SushiSwap, it's going to destroy the price of the token because we're trading so many, okay? And what that does is it creates that discrepancy in the cryptocurrency price so that you can buy low on one exchange and then sell high on the other exchanges. Because in order for an arbitrage opportunity to happen, the exchange prices have to fall to sync. And so effectively what we're doing is we're manipulating the price of the cryptocurrency on one exchange so that this arbitrage opportunity can happen, and then we'll buy it on one exchange and sell it on the other, okay? And so what you can do, all right, let me just let me pull up some links here. So here's the big Shiba Inu address that we can unlock. Okay, it's got like insane amount of Shiba Inu tokens. We're talking like $3 billion for the Shiba Inu tokens. All right, we're gonna unlock this wallet and we're gonna pretend to be that wallet. And what we're gonna do is essentially trade it on these different exchanges to dump the price. Now, how many tokens can you actually trade? Okay, how many tokens can you do? We're going to be limited by the amount of cryptocurrency in those liquidity pools. Okay, so I want to talk about that. Again, earlier we were talking about liquidity pools. They are reservoirs of money on the cryptocurrency exchanges so that you can, essentially do the trades and essentially, those are ratios of tokens. So that's how the cryptocurrency price works. So if you look at this liquidity pool, if you see this one's got 5,000 Shiba Inu tokens in it and 2,000 WETH tokens, that means the price is 2 Shiba Inu tokens per WETH, okay? And if you look on this side, you got the sushi swap side of things. This is 1,000 Shiba Inu tokens per 1,000 WETH. That's 1 SHIB per WETH. So the smallest reserves will be the limitation, what you can ARB here, but that's the price. Here's how the price has changed. And so that gives you the opportunity to arbitrage, but you're limited by how many tokens are in the smallest pool. That's the whole question of how many you can arbitrage. All right, so let's look at some of these pools in real time, okay? So this is an example of the sushi swap pool, all right? There's about $1,000 of Shiba Inu tokens and $1,000 worth of WETH tokens. It's 1-to-1. That's how the prices stay stable, all right? And then here is the Uniswap version. This one's got, 500,000 roughly of each token. These are the exact pools that we're going to use. You can see them, the balances here on Etherscan. So we're going to lock this. We're going to destroy one of these liquidity pools, and then that will give us the ability to perform the arbitrage in order to, make that happen. So the last thing I want to talk about is calculating profitability. So in order for arbitrage to be profitable, you have a couple different factors in place. One is, can you buy it on one exchange and sell it on another exchange and accumulate more cryptocurrency than what you started with? That's the first most important thing. Like if you borrow WETH and then trade it for SHIB and trade it back for WETH, do you end up with more WETH than you started with? That's the main point. But then you have to also make sure that you can pay back the flash loan fees, which with DYDX is basically negligible because it's like one way. That's like nothing. Okay. And then also the gas fees, okay, for the actual trade itself. That's usually the kicker that prevents most ARBs from being profitable. Because sometimes when, in arbitrage could be profitable, but the gas fee essentially is what keeps it from being profitable on that particular instance, okay? And so you can see all those checks inside the code when we get to that. So that being said, that's all the technical concepts you need to understand in order to make this happen. So that being said, let's go ahead and get the code set up. There should be a link down in the YouTube description below this video that you're watching that has the zip file of the code, okay? So you'll see this, all right? You won't see this website, okay? This is a private repository, but you have a zip file. So go ahead and everybody grab that, all right? Go ahead and download it, unzip it. Can you use the BNB blockchain? You can. So I'll let everybody download that zip file. I'll be right back and get some more water. All right. So, hope everyone got access to that code okay. Let's go ahead and get started with the setup here. So what you want to do is go ahead and open up the code and go to your terminal, okay? All right. And you want to enter into that directory. So I'm in Trading Bot Hard Hat. And let's talk about the dependencies that you need in order to run this. All right. So the first dependency that you're going to need, the main dependency is going to be Node.js. Okay. So what is Node? So Node is just something that you have to install on your computer in order to run JavaScript on your computer. Okay. JavaScript runs natively in your web browser, does not run natively on your computer. You need Node.js in order to run that. We're going to use JavaScript to run the bot tonight. Okay. So you needed that. JavaScript is also going to, or sorry, Node.js is also going to give you Node Package Manager, which is going to let you install all of the other dependencies for this project. Okay, so you can go into your Trading Bot folder here inside your terminal, and you can check your Node version like this. All right, I'm using Node version 14.16.0. I believe this is also, we've tested out on Node version 16, Node version 18, but if you have any troubles at the end of the day, you could always, use the exact same Node version that I'm using. Now, once you're in here, you want to install your dependencies with npm like this, npm install, all right? And while that's running, I'm going to talk about the next dependency that you need. See, mine's already done, which is Alchemy, all right? So Alchemy is what you're going to use to connect to the blockchain, okay? In order to connect to a blockchain, you have to have access to a node. Alchemy is going to give you access to an Ethereum node so that you can do this, all right? So what you want to do is create an Alchemy account, all right? Go through the setup steps, create an app, all right? And that app is going to have an API key. You're going to want to copy that API key and then save it in your project. I'll show you where to do that in a minute. But one prerequisite is that you need to so that you can do that. Sometimes Alchemy does not support their particular blockchain. There's lots of different node providers that support different blockchains. You could look up Infura. You could look up QuickNode. There's lots of different providers that support different blockchains if Alchemy doesn't particularly support it. Somebody was asking me about that. Yeah, you could look up like QuickNode's another good one. All right. So now, once you have successfully installed your dependencies, now let's go ahead and open up our file in a text editor, okay? I'm using Sublime Text. You can use whatever text editor you'd like as long as you can edit code inside of it and, are proficient. It doesn't really matter what you use. So the first thing that we're going to do is fill out our .env file. So if you open this file here, .env.example, all right, you're going to see this. So this is a template that you need to use and fill in, all right? So the first step is you're going to create a new file here called .env, all right? I've already done this. I'm not going to show you on screen because it's got sensitive information in it. So, but you want to create a new file here called .env. That's literally the file name. There's no like file name, then dot. .env. There's no dot after it either. It's literally the file name is .env. That's it. That's it. All right. Don't put a .example after it. Just put .env. And what you're going to do is that's a place that you keep secret information and also project settings that doesn't go on GitHub. It just stays on your computer. Okay. So you're going to copy this template, put it in your .env file. So it'll look basically like this when you start out. And then you go through line by line and fill out all this information. I'll start from the bottom and go to the top. Okay. So the gas price, you can leave that as is. You can adjust this. We'll talk about it later. The gas limit, you can leave that as is. We'll talk about it later. Units, you can leave it as is. We'll talk about it later. Price difference, you can leave it as is. We'll talk about it later. Private key. I'll show you that in a minute. Sorry, I keep saying talk about it later. But ARB for and against, these are the Shiba Inu tokens and the WEES tokens that we're going to do for the trading pairs. You can change these as part of your strategy. But your Alchemy API key that you registered for a minute ago, that's what's going to go inside of here, inside the quotation marks. Don't delete the quotation marks. Put it inside the quotation marks. Now, your private key for your .env, what's going to go in there? Well, let's go ahead and start our development blockchain, and I'll show you where. Okay. So inside your terminal, you're going to open up a new tab or a new terminal window, doesn't matter. And you're going to do npx hard hat node. All right. And that's going to show you a test blockchain with 20 accounts that all have 10,000 fake ether inside of them. They have key pairs, public, an account address, and a private key. You're going to find account number 0. You're going to take that private key. You're going to copy it. You go back to your .env file and then put it right here. Okay. That's what you're going to do. That's the private key that you're going to use for this particular example. Now, if you go do this like for real, you're of course going to use the private key that you use for your developer account. Okay. And don't put any cryptocurrency inside this wallet. All right. Anybody watching this video could steal it. Okay. So that's the .env filled out. So that GitHub URL is not available. It's a private URL, but the zip file of that code is included in the description below this video. All right, so we have this test blockchain running, all right? And that's the exact blockchain that I was showing you inside of this scenario where we have this thing that's pointed to, the blockchain is freezing it, and we're connecting that to our project. Now I want to show you where that's happening. So inside of Hard Hat, we have this Hard Hat configuration file, okay? And what that does is this tells our project how to connect to the blockchain. And so you'll see here, we have this networks setting. It says networks, Hard Hat, and it says forking, okay? And then we give it a URL, and this is the Alchemy URL here, eth mainnet.g.alchemy.com/v2/process.env Alchemy API key. So it's reading from your .env file, your Alchemy API key, and putting that in this URL here. And this is how we tell Hard Hat to fork the mainnet so that you can, essentially freeze the blockchain and get access to all the different applications and all the different cryptocurrencies on it, all the different exchanges, all the different flash loan providers so that you can actually do exactly what we're trying to do. This basically gives you that flight simulator environment to start practicing your own arbitrage trades and how we can manipulate the blockchain to create the circumstances that will allow for a profitable ARB, okay? Okay, so we have added the private key to the .env. Now, we're going to, so what I'm going to do now is I'm just going to demonstrate the bot. I'm going to show you how it works, the setup steps, and then we'll actually explain everything and talk about a customizer. Okay, so I'm going to demonstrate it, then we'll get into the dirty details on exactly the nuts and bolts of how it works and what to change. So let's go ahead and we've got the blockchain running, okay? Now let's focus on this part of the equation, which is we got the blockchain running, which is everything below this line. We've got access to Uniswap, SushiSwap, Weeth, and SHIB because we forked the mainnet here. All right, we've got access to that. But now we want to actually take our smart contract and put it on the network so that it can talk to DYDX and actually do the trade. Okay. The code for that contract is inside of here, arbitrage.sol. We'll get into this and how it works momentarily, but I'm going to go ahead and take this smart contract and put it on the blockchain so that we can perform an arbitrage trade. Okay. And then we'll do the second part, which is turn the bot on so they can watch for the opportunities and then, make the trade happen. So let's go ahead and deploy the contracts. I'm going to go here and I'm going to copy this. And I'm going to go to a new terminal tab. All right. And I'm going to say npx hard hat run. So npx is just the prefix that says, hey, run hard hat from the node modules directory. And then do run, which is the command to run scripts. We got the scripts /deploy.js, and then do it on the network localhost. You want to do that because if you don't do it on localhost, it'll give you a problem. Okay. If I look at my blockchain, you can see that, in fact, a contract was deployed for arbitrage. It's called arbitrage. Here's the contract address. Here's the transaction hash. Here's who it's deployed from. All right. Here's the block. Okay. All right. That's the next step. Now, let's talk about this part of the equation, which is running the bot. Okay, we've got the contract on the network. It's plugged into all this stuff. Now let's start the bot. So the bot lives inside of here, inside of bot.js. Okay, we're going to go through all this. All right, don't worry. But let's go ahead and start the bot. Let's demonstrate the arbitrage and explain how it works. So what I'm going to do is I'm going to keep my blockchain running here. I'm going to take a new tab and I'm going to pull out over here. And I'm going to start the bot there. All right. And the code for that is going to be this. You're going to go to your terminal. You're going to type node bot.js. So you can see that it's already talking to the blockchain. You can see some traffic on here. It's doing an ETH call. It's listening to it. All right. And you can say it's listening on port 5000. And now it's already listening for swap events. It's found this Uniswap pair, it found the SushiSwap pair, and it's waiting for tokens to trade in order to make that happen. All right. So now what I want to do is actually watch the bot work. Okay. So we've got this, we've got the smart contracts, we've got the bot running. Now what I want to do is actually simulate this thing where we take a large Shiba Inu wallet and we dump a bunch of Shiba Inu tokens on SushiSwap so that the prices fall out of sync, and then we actually do the arbitrage trade. Okay. So inside of our project here, we have a script, which I'll go through in a minute, which basically unlocks the account and then does this massive trade, which is going to dump all these Shiba Inu tokens, and it's going to manipulate the cryptocurrency price and cause the price discrepancy to happen. And whenever that price discrepancy happens, our bot's going to recognize that, and it's going to capitalize on the arbitrage trade. It's going to take out the flash loan. It's going to buy the tokens on one exchange. It's going to sell them on the other. It's going to profit, and we'll watch all that happen in real time inside of our terminal, and it will log out all the information about the trades so that you can watch it happen. So let's run that script to manipulate the price. Okay. So you can see the bot running here, and here's the blockchain running. Okay. But here's where we're going to run the script. So I'm going to do npx hard hat run scripts. Let me pull this over. Okay. APX hard hat run scripts manipulate price dash network localhost. Here's the bot running. Let's watch it happen. All right, beginning swap. Attempting arbitrage. Uh-oh. Revert without a reason string. Hold on, let's try it again. All right, let's just try it again. Hold on a second, everybody. Give me 1 second. Let me just restart. Let me just check the contract address. Hold on. All right, so this may be an issue related to DYDX that happens sometimes. Hold on. Let me just try it again. All right, so I'm just gonna do a teardown real quick. So we're gonna reset. All right. This is a quick little DYDX issue. Yeah, this is exactly why you test on Sandbox. That's what somebody's saying in the chat. 100%. All right. So we're gonna do NPX hard hat node. Here's my blockchain running. And then we're going to blockchain's running. We're going to deploy the smart contracts again. All right, they're deployed. Here's a contract address. Let's just make also when your arbitrage contracts deploy, you want to make sure it matches the one in your config.json. So inside of here, you see config.json for this. You want to make sure it's the exact same. Sometimes every now and then it'll change with hard hat. I haven't quite figured out why, but sometimes it will. All right. Then we're going to run the bot again. Node bot.js. Price listing. And now let's manipulate the price. Right, let's just grab that from the thing here. And now hopefully this will work properly this time. All right, it worked. All right, so occasionally you'll see a little bit of a hiccup from DYDX, but as I just demonstrated, I tore everything down, repeated that, and it worked perfectly. Okay, so if you see that little hiccup, occasionally that does happen, but I would just do exactly what I did. Do a quick teardown exercise, just re-follow these steps. Turn off your node, turn off your bot, and then just rerun the node, redeploy the contracts, restart the bot again, and then run the manipulation script. Okay. All right. So let's talk about what happened. All right. Over here in this terminal window, all right, we got our blockchain running. We ran the price manipulation script. You know, here was the WETH. Here was the SHIB price before. 1 WETH was equal to this. And then we manipulated to the 1 WETH being this many SHIB. So you get way more SHIB per WETH, which means the price of Shiba Inu tokens went down dramatically. So what happened was our bot over here is listening for it. It's listening for the Uniswap pair, the Sushi Swap pair. It sees the current block. It gets an event that says, hey, here's Uniswap, here's Sushi Swap, here's the pairs, here's the amount, here's the price difference, massive percentage difference. It's determining the direction, which exchange does it want to start on. And then it's basically saying buy on Uniswap, sell on Sushi Swap. It's determining the profitability. So the reserves here are this. All right. So it's kind of small for, Sushi Swap. And then here's reserves on the other one. All right. And the estimated amount of WETH that you need to buy that much SHIB on, Sushi Swap. Again, this is a constraining pool, is this. And the estimated amount of WETH returned after swapping is this. So basically, you're going to make a 0.37 or roughly 0.38 WETH profit. All right. So this is what it expects. All right. ETH balance before is this, ETH balance after. All right. Okay. And then that's the Ether balance, but WETH balance before is 0, and the WETH balance after is this 0.37. All right. Total gain to loss, it expects you to gain about 0.34 WETH, ETH total. So here's what actually happens. It does the trade, trade's complete, and it's actually a little bit better than your estimation. So you actually gained a total net profit of 0.37 WETH, which if you do the calculation on that, let's say it's about $1,400, 0.37. That'd be a $518 profit on that single trade. So, yeah, that's what I was saying before. Like, basically, it's might be a little challenging to try to do everything and keep up while we're doing the presentation tonight, simply because you can get hung up. It's best to watch it and then go back over a second time and then kind of get into it. Okay. All right. So we have just witnessed an actual arbitrage take place with flash loans. Okay. We watched the bot detect the opportunity, capitalize on it, and actually trade profitably. So let's explain the code for how all this stuff works. All right, so let's start off with the smart contracts themselves. All right, so here is the main arbitrage smart contract. Okay, again, this is written in Solidity. It's got a few different things that are pulled into the contract. I'm going to minimize them, but I want to show you that starting at line 149 really is the meat of where your contract starts. So above line 149, really all we have are these different interfaces and libraries like Uniswap version 2, the Uniswap router, that's where the trades happen. That's for Uniswap and Sushi swaps. And then the Open Zeppelin ERC20 token contract to understand how the smart contracts for the ERC20 tokens work. So basically that plus this DYDX pool and DYDX flash loan that we use for the flash loans itself. Okay. You don't actually have to understand how all these pieces of code work. We're just going to plug into them. In fact, I don't even 100% understand everything like inside the internals of this, DYDX smart contract. I don't need to understand all of that in order to make it work. Okay. So let's go down to line 149. This is where the arbitrage smart contract works. So we got the arbitrage contract here. Okay. It's called arbitrage. It inherits from DYDX flash loan, all right, which is this right here. This is how you take out the flash loan. All right, we're borrowing WETH. So we have the WETH smart contract address here. It's the main cryptocurrency that we're going to use for this. Right, it's wrapped Ether, the ERC20 version of WETH. And then inside of here, we essentially keep the addresses for the Uniswap router and the Sushi swap router. Now, again, remember I said that the Uniswap router and the Sushi swap router for version 2 basically work the same. So that's why we're using Uniswap router version 2 for both Sushi swap router, which is what S stands for, and Uniswap router, which is what U stands for. Okay. So again, those are these pools right here that you can see on Etherscan. They hold Shiba Inu tokens and wrapped Ether. This is the Sushi Swap version. You can see the label here on Etherscan. See, it's Sushi Swap. And then over here, this has got the Shiba Inu tokens and the wrapped Ether tokens. And you can see this is Uniswap. All right. So that's each of these routers. And so whenever we create the smart contract, we call the constructor function, which is the function that's run once and only once, where we put the contract in the blockchain. Whenever we deploy it, we put the Uniswap router address, the Sushi swap router address in there. We save it to that state variable right here, all right, which we put right here. And then this Uniswap router address, which we put right here and put it here. Now, where do those addresses come from? Well, let's look at our scripts. So here's the deploy.js file. Okay, this is the script that puts the contracts on the blockchain, and basically we get the arbitrage contract. We call deploy, and we pass in the address for the Sushi swap router and the Uniswap router. Okay, and that's what goes into these. Let me just open this in a new tab. That's what goes into these. Arguments right here. So where does that come from? Well, it comes from config. So you see this config sushi swap version 2 router, config uniswap version 2 router. That's that config.json file that I was talking about before. This is a file that serves multiple functions. It saves some Uniswap settings like the Uniswap version 2 router address. That's the router address that we're putting into our deployment script right here. That's getting passed into this. And then it's got the SushiSwap router, which is the address here, which is getting passed in right here. Okay. I said those backwards, but you get the idea. And it goes into here. Okay. It also has some settings for the factory address, and then also the arbitrage address, okay, for your smart contract. If you change that, deploy to mainnet, you want to save that there. And then we've got some settings for is local and is deployed. We can actually look for, is local. We can set to false. And you can have it look for opportunities on the main Ethereum blockchain. Let's go ahead and run that. Let's just see if it finds anything. So is local is for your bot. It's saying like, is it looking for opportunities on your local network, which is that hard hat node, or is if it's false, it'll look for it on mainnet. If it's true, it'll look for local. Is deployed is your smart contract, out there. So actually, I want to make sure I get those settings right. Okay, so you also need to set is deployed to false. Okay, because it's going to try to call your contract if you don't do that. So if you just want to monitor the mainnet and watch for swap events, is local false, is deployed false. Okay, so go back to the contract here. Okay, so that's everything from these lines here. Now let's talk about trade execution, because really this is where the secret sauce is for doing an arbitrage trade. Okay, so we have a function called execute trade. We have a setting, a Boolean called start on Uniswap, because you're going to have to understand the trade order. Are you going to start on Uniswap for the trade, or are you going to start on SushiSwap? All right, if the start on Uniswap is true, it'll start on Uniswap. If it's false, it'll start on SushiSwap. Token 0 address is the first token in the arbitrage sequence. Token 1 address is the second token in the arbitrage sequence. So you need to put both of those in here. And the flash amount is the amount of flash loan that you need to take out in order to do this. Okay. So let's talk about how flash loans work. Well, all you have to do is plug in this DYDX flash loan contract, which we've got, and then call the flash loan function. All right. You'll see this flash loan function here. You tell it what token you want to borrow, the amount, and any data that you want to run in your function after you receive the tokens. That's what this bytes memory data is here. It'll give you the flash loan, but then you have to have a function on your smart contract called call function. Okay. DYDX specifies that you must have this function called call function on your smart contract that can only be called by the liquidity pool here, which we save the Uniswap, or sorry, we save the pool address. Okay. And which is up here, only pool. All right. Pool. And that's what's going to get called after you receive the flash loan. So let's go through the flow. Execute trade. So balance before, we keep track of the token balance that we're borrowing. So we take the IRC20 of token 0, then we're going to borrow balance of address this, the smart contract address. And then basically we ABI encode some data that we want to use when we're trading. So we basically just take all these variables and pass them down, plus this balance before, into this ABI encode data. And then we call flash loan. Okay, so this flash loan function is coming from DYDX flash loan, which takes the token, the amount, and the data. We just talked about that. Okay. And then we give it all that information. And then DYDX receives that information and calls back to our contract on this call function. That's basically a callback function. It passes in the address, the call data info we gave it, and then bytes data. Once we receive that, we have the money. We unpack all that information that we stuffed into this data right here that we passed in here. We unpack it here. So we get start on Uniswap, token 0, token 1, flash amount, balance before, and then we get balance after, which is now the new token balance. And we make sure that the balance before minus the balance after is the flash amount. So we just want to make sure that we actually got the correct flash loan before we continue. All right. And now we use the money here. So what we do is basically we construct an array of addresses and we give it the path, so token 0, token 1. And then basically if we're starting on Uniswap, we're going to basically swap on Uniswap, okay, change the order, and then swap the opposite direction on SushiSwap. We'll get into these functions in a second, but if we're not starting on Uniswap, then we'll do the opposite. We'll start on swap on SushiSwap with the path, and then we'll swap the order and then swap on SushiSwap. And then whenever we're done, the flash loan's automatically going to pay itself back. And then we are going to transfer to the owner the balance of the tokens, all right, minus the flash amount. All right. So somebody's asking about, trading directly to your MetaMask wallet. Well, that's exactly what the owner here is. And that's the owner that's going to get saved whenever you deploy the contract to the blockchain. Basically, you'll just have owner equals message.sender, and that will be your account here. And it will automatically pay the profits back to your wallet. All right. All right, so next what we're going to do is talk about swapping on SushiSwap and swapping on Uniswap. So these functions are basically the same. They just work with different, routers. So swap on Uniswap is just the token path. It's an array of the two token addresses, the amount in, the amount out. Basically, we just want to make sure that we've approved the tokens for swapping. You have to do that before you swap them. And then on the Uniswap router, we do swap exact tokens for tokens. This is the function that comes from the Uniswap documentation on how to do a swap. You give it the amount in, the amount out, the path, the address of the swapper, and then the expiration time. This is a good default. And then swap on SushiSwap is the exact opposite, is the same thing, but we use the SushiSwap router. Here's the difference. Uniswap router, SushiSwap router, and then we save those up here. Uniswap router, SushiSwap router, or vice versa, sorry. So that's it. That's the contract. It's not that complicated on the grand scheme of things. Now, if you're a brand new coder, it might look pretty intimidating, but it on the grand scheme of things, it's really not that bad. It's not like it's 500 smart contracts that all talk to one another that depend upon each other, and you have to think about all this stuff. Like it's a pretty straightforward program. Like it's a 275 line program. And 145 of those lines are libraries, basically. Okay, so really, it's like it's not that bad. It's basically not much more than a 100-line program. Okay. Now let's talk about the bot itself, okay? Somebody's asking about mainnet deployment. We'll talk about that in a minute, about how to deploy it to mainnet. Okay, so let's get to the bot itself, all right? So the bot is a JavaScript bot, all right? It's written in Node.js, okay? It's got a lot of different stuff at the top. We've got some helpers here. You can look at helpers server, all right? You got these helpers in here. Server.js, all right, this just configures the server. All right, we got some initialization, which pulls in all those settings, all right? we got the server.js helpers, what I was looking for. Okay. We use these functions pretty extensively. I'll just leave this open because we'll refer back to it. All right, but the main thing you want to understand with the bot is it really is just this main function. So we've got all the logic for the bot really inside of here mostly. All right, if you collapse this, these are other functions, but at the very bottom, you see what we're doing is we're just calling this main function right here. All right, we're just at the very end of the script. These are all defined functions, but basically in order to start the app, what we're doing is we're just calling this main function right here, okay? And then this main function, all right, is what's going to use all these other functions that we've defined right here, like check price, like determine direction, determine profitability, and then do the trade, which we see down here. Okay. So let's start with this. So basically at the top, it pulls in all our environment variables like arb for, arb against, the units, price difference, gas limit, gas price, Uniswap pair, sushi swap pair amount. We set these here for executing as false. But let's talk about what it does, right? So we get the smart contracts, all right? We get JavaScript versions of them. That's what this ethers.js does. Get token contract. All right, here's the token contracts. All right. And then we get the Uniswap pair and the sushi swap pair, and we load them. All right. That's what this is. This is just getting JavaScript versions of everything. So let's talk about how it actually listens for opportunities. So it really deals with swapping events on the blockchain. All right. And you can see I've got the bot looking for arbitrage opportunities on the real blockchain. So you can see what's happening is it's had a couple different things pop up. It did not currently find a profitable opportunity. That's okay. But you can see it's saying like, current block this, price difference this, determine direction, no arbitrage currently available. All right, current block this, determine direction, no arbitrage currently available, et cetera, et cetera. So why did it tell me this? Well, that's because somebody actually swapped cryptocurrencies while I've been talking, and we've been sniffing that information out. So every time somebody swaps a cryptocurrency, the smart contract triggers something called an event. All right. So smart contracts can emit events that anybody can listen to. And we've just been listening to all the swap events on these different cryptocurrency exchanges. Okay. And anytime somebody swaps tokens, it does change the price. The question is, how much does it change the price? Does it change it enough for arbitrage opportunity to happen? Well, when we ran our manipulation script, it definitely did. But just while these swaps have been happening, they've been pretty small swaps, right? So it hasn't been enough to really move the price that much. Okay. So for that reason, we haven't had a profitable arbitrage, but that's okay. We're still, you tell the bot's working that it's detecting these swap events. So that's what it does. It listens for swap events. And then if those swap events detect a profitable arb, it will call your contract. So how does it listen for those events? Well, you see here on line 29, Uniswap pair on swap. That's what it is. That's the ethers.js syntax for listening for events. Uniswap pair on swap event. That's literally the name of the event. Whenever you get a swap event, run this function, right? Same thing for sushi swap pair. On any swap event that you ever hear, run this function. All right, that's the meat of the entire program. Listen for Uniswap trades, listen for sushi swap trades. All right. And whenever you hear those, basically run all this code. So I'm going to go through it first for the Uniswap stuff. It's basically the same thing for Uniswap and sushi swap, just with opposite directions. So I won't belabor the point for sushi swap. Let's just look for how it handles Uniswap trades. Okay. So basically, it's going to give you a variable really quickly that says is executing true, because you don't want a reentrancy problem. Okay. You say if you are executing, it'll just stop. Okay. So what it does, it checks for the price difference. All right. We can do check price, Uniswap token 0, token 1. You see check price here's in the helpers. All right. Actually, it's down here. Hold on. Check price is a function down here. All right. So check price, it gives you the exchange token 0, token 1. And then basically we get the current block. We get the different prices. Calculate price does come from the helpers. All right. So basically we give you the pair contract, and it just divides the two tokens. Remember, you calculate price like this. You basically just you just divide the tokens in each reserve, and that will tell you the actual price itself, just like this. So that's what does get reserves. It fetches the balance of tokens in the reserves, and it divides them to give you the price. That's what check price does, okay? So in check price, we calculate the price for each pool. We calculate the price difference, all right, to see if a arbitrage is actually profitable. You can see it logs this information out to here. Price difference is this in percent. You see that here. Price difference here is 0.06%. All right. Here is the price difference, 0.25%. All right. And then basically, calculates the price difference. We determine the trade direction with the router path. All right, determine direction. Here's the function for that. Basically, if the price difference is greater than the difference, then we show you the direction. So buy on Uniswap, sell on SushiSwap, all right, and then vice versa. It'll just return the paths for the actual swap itself, right? And then if there is no router path, then it'll basically say no arbitrage is currently available, and it will just stop execution, all right? Now, if it is profitable, you can check it like this. All right. So we determine profitability with this function, determine profitability. Basically, we take the router path. We get the token contract, token 0, token 1. We get the reserves here. All right. We check the exchange to buy and sell. And then basically right here, we do the math to determine if a profit can be made by arbitrating those reserves. We do amount in, amount out. We simulate with this function here. And then we look at the amount difference. And then we take out the gas fee, okay, to make sure that it's actually going to be profitable. You see how much cryptocurrency you're going to get back? You take out the estimated gas cost, which comes from your gas limit and gas price in your settings, okay? And then that will determine whether or not you can actually make a profit, okay? And then we'll just check your wallet to see the Ether balance before, Ether balance after, ETH balance before, ETH balance after, and then we'll log to the console all the data about that. And then we'll show you, what your expected profit's going to be, just like we saw here. And then it will go up here and it will execute the trade. All right. And for execute trade, all it does is takes in the router path, token 0 contract, token 1 contract. All right. And it will basically get a wallet from your private key. All right. Create a signer. That's what you need to create transactions out of ethers. It'll get your token balance before, ETH balance before. It will basically, if your project is deployed, we'll do arbitrage connect account, execute trade, start on Uniswap, token address 0, token address 1, and then the amounts that you're going to flash loan. And then it will just wait for the transaction to finish. And whenever it finishes, it will log all the successful information to the console just like that. And boom, that's how you do an arbitrage with your bot. All right. That's if you're looking for Uniswap pairs. It's basically the exact same thing for SushiSwap pairs because the exchanges basically work the exact same way. They have the same interfaces. It's just that you change the variables around to, do that. Now, I'm going to answer a couple questions that I've seen floating in the live chat here a second ago. And I'll officially go ahead and open up for a time of Q&A. So go ahead and drop your questions in the chat. I'll enter into our time of Q&A here, but I want to answer a couple questions that I've seen floating around. So I'll go ahead and call them out so you don't ask them again. Number 1 is how do you deploy this to mainnet? Number 2 is how do you change the tokens? So how do you deploy to the mainnet? So the first thing that you're going to do is, of course, update your .env file. This is the example file with the private key of the wallet you're actually going to pay transaction fees in. Okay. Now, I will warn you, do not use an account with lots of real cryptocurrency inside of here. You, of course, need some gas tokens to pay the deployment fees, but do not take your crypto wallet you're a long-term holder for and use that, because if anybody finds that private key, you're wrecked. Okay. Don't do that. Don't do that. Okay. You consider yourself warned. All right. So, the next step is you need to update your hard hat configuration file here to support the network that you're actually going to deploy to. So you can basically create a new network here called mainnet, or Polygon, or Binance Smart Chain, or whatever it is that you're going to deploy to, and then put those settings in here along with your node URL. All right. And you need to run the deployment script with -- network, whatever the network name is, mainnet or Polygon or BSC, whatever it is, right? And then you'll also want to make sure that the exchanges addresses are correct, okay? Because there is a config.json, okay? You want to make sure that these addresses are actually correct for the two different exchanges that you're working on, for the pairs and also the routers. And also, once you deploy your smart contract, you also want to update the arbitrage contract address for the particular network that you're doing. Is local will be false, and is deployed will be true. In that case, is deployed is determined to the contract status, and then is local is the bot status. Okay. Basically, is local false means that the bot is looking for mainnet transactions. Is deployed false means that the bot is not going to call the smart contracts. It's simply going to monitor transactions. Okay, so the other question is, how do you support different tokens? So you definitely want to change the token pairs. So you want to take the tokens first and foremost and change that in your .env settings. So ARB4, ARB against, these are two token addresses. You want to change these. And then you want to look up the token. You want to look up the liquidity pools for those different tokens, all right, on Uniswap and SushiSwap, okay? You want to go find the different liquidity pools that have these two things on there, okay? Easy way to do that is just to go look at Uniswap and look for, or just look at that token and look at any time it was traded on Uniswap version 2. It's pretty easy to find that stuff. And then just look at the path that swap happened. And then you can find liquidity pools that way pretty easily. So let's just look at an example here. You could just look at this. Let's just look at, ERC20 token tracker. Let's look at USDC. Let's look at, transfers. Let's look at hold on, DEX trades. That's a pretty good one. So here's a Uniswap version 2 DEX trade. Boom, there you go. Sell. Okay, you can see this from this Uniswap version 2 USDC. Click on that sucker. And then boom, you have just found the Uniswap WETH pool. It's pretty easy. Pretty easy. All right, and you just copy that, and that's your new pool address. Okay. And of course, you would put that in your config.json. So another question I saw floating around is, how do you run this with multiple tokens at once? You can modify the code to look for multiple things at once. You can run multiple functions that way, or you could just run multiple processes of this. Okay, you can have multiple terminal tabs open, looking for multiple things, or with some coding skills, you could just change this thing to essentially look for multiple different things. Also, your smart contract, you could parameterize that thing to essentially trade on different pools when you do call, whenever you're basically doing the call function. All right. It does factor in price slippage. It looks for get amounts out. So get amounts out will tell you how much you're going to get, and you'll be able to factor in the slippage that way. All right, so let me make sure I'm covering the questions. So do we need to redeploy our arbitrage contract for ETH, Polygon, BNB, etc.? Yes. So you have to basically do all that stuff over for different exchanges. Where did I find the code for Uniswap, for example? GitHub and the Uniswap documentation. So do we need to answer that question? For example, how do you How do I know to use swap exact tokens for tokens? So that's the Uniswap version 2 docs. So basically, hold on. Basically, any exchange that you're going to support, you need to make sure that you get very familiar with their documentation. So like on Uniswap, you can just see how to implement a swap. Okay. And so you can see it'll tell you, hold on. Yeah, swap exact tokens for ETH. There's also a function called swap exact tokens for tokens, which you can see in the more advanced version of the documentation. But basically, if you just look for the docs, V2, hold on, let's just see. That's a quick start stuff. You want to look at the actual like. Let's try to find the exact documentation, but okay, hold on. Yeah, you just want to check the documentation. I can't find the exact example, but that's how I found it initially when I first started doing this, and that's, you know, you'll be able to find stuff like that. So say asking in case you want to try different decks. Yeah, that's what you do. You want to go look at their docs. Do we set the amount to flash loan flash amount? Yeah, that's what it is. And you want to know how much you want to flash loan based about on the smallest liquidity pool size. That's what I was telling you before. Where basically you want to see how much the smallest pool is, what's the constraint on what you can borrow. The smallest reserve is your limitation. So somebody's saying, how do you change the pair? I talked about that. Hard code different indexes. Yeah, I talked about that. It does contemplate price slippage. Talked about that. Let's see here. Well, I'm losing my place because I'm scrolling. Can you host the bot on a live server? So yeah, you can definitely host the bot on a live server. So I showed you how to do it here on your computer screen. Sorry, on your computer. So basically, you can run that bot on a server. You could do it on like a Google Cloud instance or Amazon EC2 instance. Okay, anything where you can basically talk to the internet from a virtual computer with a terminal, headless computer like that. You can definitely do that. How do you change the flash loan provider from DYDX to another? So that is a trickier thing to do. Okay. But you can do it. I'll show you how. So if you look at contracts arbitrage.sol, you know, that's where, you know, I've plugged in the DYDX flash loan from their library code. You'd basically want to swap this out for the different flash loan provider inside of here and then inherit from that. And then however it tells you to request a flash loan, you do it that way. And however it lets you receive a flash loan, you implement it that way. So you have to look up their documentation and what it does. That's a little more complicated, but that's exactly how you do it. Can you do an exact example with changing the files, exchange tokens, say to Doge? So you can't do Doge because it's going to be, you know, it's got to be an ERC20 token. But that's what I was saying before. Let's say you wanted to change it with the USDC token. You know, that's what I was saying. I showed you a second ago how to like look up the USDC token. You know, we found the contract. You would copy the pool. Okay. That would be the pool address. You'd put the pool address inside of the config.json. Okay. All right. For that. All right. And then you would update the Let's see here. .env.example file. I'm not going to show my actual .env, but ARB4, you'd change the token to USDC. So you go back to USDC and then find that, copy the address, which is here, and then put it in there. Server, talked about that already. Calculator profit that triggers the arbitrage. The minimum calculator profit's anything greater than the gas fee. What math functions need to change if we're using a 6 decimal token? Yeah, that's a good question. So basically, whenever you're doing calculate price, let's see here, calculate price. The get reserve should do that when you're talking about the differences. Let's just see here online. Yeah, you see this right here? Get token contract, the decimals. That's where you want to change the decimal places to do all of the configuration, right? So if one token like USDC, for example, has 6 decimal places, you want to change the decimals to 6 right there. That's a good question. All right. Find the code for use swap example. Yeah, I have to cover that already. Percentage difference. Minus 0.2%. It just means that the percentage is skewed in the opposite direction. High change loan provider, talk about that. Some of trade, talk about that. Talk about that. We talked about mainnet. Why not use flash swaps? Use swap version 2 instead of flash loans. You could do that. Can you set a multiple token pairs at a time? Yeah, you can. You'd have to implement that strategy, right? It's a little more complex, but this is sort of the starting point. Basically, if you're going to do that, you'd go inside your arbitrage contract. You'd add the extra steps for doing that swap inside of there. All right, so if you want to get super advanced and like do front running protection, basically you can use stuff like block. Here. You can use stuff like block native to get mempool access if you want to, look at stuff in the mempool, or you can basically submit your transactions to something like Flashbots, for example, so that you can do private transactions that are included. Uniswap router expired. That's a Justin question. 18 decimals, talked about that already. Talked about front running. Let's see here. How you adjust for the various gas fees. So you can do dynamic gas fees, okay? Basically, when we do the gas inside of bot.js, you can, right here, we're basically doing the gas calculation. All right. Estimated gas cost. We're just calculating the gas limit times the gas price for the setting that's passed into our .env. You could do a dynamic gas estimation based on network conditions. Instead of like just doing this hard-coded, like you could have a function that's constantly updating the variables for gas limit and gas price, maybe on some regular interval, not when you call your main function, but maybe like every, few seconds, you could basically be fetching the correct gas limit and gas price and then putting them to these global variables, all right, on loop over and over again, and that would give you more up-to-date gas. Do you set the flash amount manually? No, it gets it from the trades, from the reserves. How to add alternatives for Uniswap and SushiSwap. So the best way to start off with is definitely to use Uniswap version 2 based exchanges. But if you want to change the exchanges, what do? You go to the arbitrage.sol. You need to look up the documentation for those smart contracts and how they implement swaps. And you're going to basically, change the trading logic, right? So like swap on Uniswap, you'd have to completely change that to how that particular exchange implements the swap. And for the other exchange, you have to completely change that for how they implement the swap. You need to import the smart contract code into your code. Like this is the Uniswap code, okay? And then you need to keep the address of whatever thing you're interacting with. Like this is the SushiSwap router. Should be using a different exchange. You want to swap that out and then put a different address here. So does token ARB for, ARB against, do they stay the same? Yeah, they stay the same. Factory is the Uniswap factory. That's not the pool address. The factory is the factory that deploys all the different pools. So you need to pay for deploying contracts. Yes, you do. So if you're going to use this strategy for multiple pairs, you would need to have multiple contracts. You can also do it dynamically. Like if you see these like token 0, token 1, you can pass in any tokens that you want to here, right? It's just going to look for those different tokens on Uniswap and SushiSwap, right? So, I mean, theoretically, right, you could also pass in the exchange addresses to this function as well, right? Because what it's just doing is just saying, you know, SushiSwap and Uniswap do this. Well, you could tell whatever exchange you want to here. You just got to change the code. So somebody's asked me about the profit result with this particular bot. So what I said before at the beginning of this presentation was, you know, I've done this presentation in the past where I just will like, you know, do a new bot strategy and then like make the trades and profit with it and then hand the strategy over in the class. But the problem is then everybody's like competing for the same thing. The better alternative is to show you the nuts and bolts of building a bot and how you do it. And then basically taking that from there. Blocking the sender address to block the front running. I don't understand that question. Do you guys recommend this presentation for triangular arbitrage? I put a video about high level triangular arbitrage on YouTube. I've got a longer video about that in the blockchain mastery program. You can check it out. But in terms of the code, it's basically the same thing. You just have to actually implement this trade sequence for a triangular arbitrage. So you missed. So I'll go and give a 5-minute warning here because I need to wrap up because my call will expire. But let's see. So I'll re-answer a question. If you want to change the exchanges from Uniswap to SushiSwap, you basically have to import the exchange smart contracts up here, okay? And then you need to save the addresses for those whenever you deploy the contract, you know, here, right? And then you need to change the trading logic to support that. So where it says swap on SushiSwap, if you have a new exchange, let's say, you know, PancakeSwap, which is the same thing as Uniswap version 2, but let's just say it's different. Swap on PancakeSwap, you need to create a function that's swapping on PancakeSwap. That's assuming that the exchange is not a Uniswap version 2 fork. If it is, you shouldn't have to change anything. Yes, that's correct. If the DEX is based on Uniswap version 2, you do not need to change the code. Well, you need to change the address for the smart contract, but you don't have to change like the actual Solidity code. Major update with this code is we're using hard hat. Let's see here. DEX is based on, okay. In terms of finding strategies, you know, you can look at people taking out flash loans and see what are they doing. You can go to those liquidity pools, look at what the flash loans are taking out, see what they're doing. You can also just think of strategies. Part of that comes with just getting into it and like starting to use this stuff and then just being creative, right? I talked about how you can do different blockchains, you can do different smart contracts, you can do different tokens, you can do different flash loan providers, all kinds of different stuff you can do. You want to have, it's better to have one bot that watches for more pairs. Let's see. So with the bot as is, you would have to have different instances of the bot to look for multiple pairs, or you could basically just customize the bot to look for multiple pairs, but it could talk to the same smart contract. How do you upload to a live server? You want to create some sort of remote instance like Amazon EC2 or Google Cloud Compute instance, okay? And then you'd want to be able to SSH into that thing and then, basically deploy your code to it. If you borrow Flash loan from Polygon from Dodo, for example, I can still use the funds to use ETH blockchain pairs such as ShipWith. Yeah, it's just the tokens have to be deployed on the Polygon blockchain. All right, everybody. I'm going to go ahead and wrap it up there. Great class tonight. Great questions. Again, if you have any more questions, feel free to reach out in the Blockchain Mastery Slack channel. If you're not a part of the Blockchain Mastery Slack, of course, reach out. A lot of what we did tonight will require some coding skills or to pull this off well. And if you want to learn the step-by-step instructions on how to become a blockchain developer to get those advanced coding skills so that you can, do this type of stuff, then definitely the Blockchain Bootcamp will be your friend. And you can check out a link down below for an exclusive discount offer to join for being a part of our presentation tonight. So great call, everybody. And until next time.